All right, so I'm going to jump ahead. Um, and for now, I'm going to skip the communications and network security um, because that is a big domain. And I think that probably, based off of my experience, a better use of our time if we go through identity and access management, and then maybe put the software security tomorrow morning, and then come back to communication network security for the interest of time at the tail end of tomorrow. Um, so hopefully you guys will understand that. All right, so with this next domain, the identity and access management domain, this is, to me, probably one of the most important ones, if not the most important one. And I say that because everything within anything we do is related to IAM, identity and access management. So that means that it has the hooks or the tentacles, if you will, into all of these other domains, right? And I say that because you probably are already familiar with basic identity management, but have you taken a look underneath the hood to maybe get a little bit better understanding? And if not, that's okay, because we're going to go through some pretty cool stuff today. And it starts with what you see up on the screen right now. So being able for us to control access and manage anyone's identity is super important, not only for physical and logical assets, but also because typically we are looking for the IAAA, which is the identification, authentication, authorization, and accountability. And so when we go through and begin to have discussions about anything dealing with identity and access management, it's important for us to know that everything kind of comes around this IAAA concept here. How do we identify people? How do they authenticate? Can they authenticate? What are they authorized to see? And how do we hold them accountable? So those are the premises, if you will, to being a good practitioner of identity and access management. So let me ask you a question. And don't just answer, think about it here. Which one comes first? Yeah, Ryan, good. Name is good. Alicia, good. Good, Jennifer. Good, Brandon. Yeah, and I always think about it, from the perspective of, let me give you an example. Let's say you get pulled over, right? Pulled over, cop pulls you over, and all of a sudden, he's walking up to the car. First thing he's going to say is, license and registration, sir. So the license would be the way that he can identify me, but then he'll also run the registration and the license back against his system to authenticate me, to see if there's any outstanding tickets that I haven't paid, or warrants from my arrest, or whatever. And because of that, that's really used in that context, as well as within our corporate environment. So it kind of transcends the different components there. But in addition to that, we need to be able to figure out how we can authorize people and be able to manage that authorization. We'll take a look at the access control components, but also some of the attacks that come through access control, and a life cycle that includes this thing that's called provisioning. Provisioning. And that's a key word here based off of identity and access management. And so really everything that is in our corporate infrastructure, whether it's physical components and logical components, we call those assets, right? Those assets could be data, it could be software or systems, or maybe hardware, or things that can be depreciated. And we need to be able to facilitate how someone can access that. Now, we could have a truckload of different components, or allow each one of these to be controlled independently, or we can put it all in one and then be able to manage this entire component with a single pane of glass. And really it all comes down to what kind of control do we want over the system. And you're familiar already with many of the different types of security controls that are out there. And the different types are shown up here. We've already talked about these in very good detail. But I mean, some of the things that consider are, what are going to be some of the policies that we'll implement. What are we going to do for any gates, guards, and guns? So anything dealing with physical security, we want to make sure that we account for that on the physical access control side, right? The technical components are, what are we using? What software or system are we using to control the security policies? Right? What are we using to control it? And so, the locks, the fences, the lights, and even somebody said yesterday, the moat around our place. These are all things to think about in the physical side of the house. So really, those are decisions that we throw over. Whether or not we have a Chinese wall model, that's a different story. But we'll throw over the fence to senior management, because they really need to decide what role security will play in the organization. And that includes, but it's not limited to, coming up with these administrative goals and objectives. And giving us directions or directives to how we should try to support any key tasks that allow us to meet those goals and objectives. And the first piece to building any security foundation within our organization is going to be the security policy. And so that's why that keeps coming up, rearing its ugly head here, is the security policies that are out there really is the way that we can delegate the development, we can support procedures, we can look at standards and guidelines, and really indicate which people control what things inside of our environment. These work typically at the very top layer. The administrative controls really work from the top down approach at the top level, right? So we've mentioned that a few times throughout the week so far. And usually they are done by supervisors or management or a whole bunch of things that are there. That can include, but not be limited to, security awareness training, which we have some great security awareness training we'd love to show you. But also, we need to be able to show that none of these things that we're implementing are affecting the bottom line, and the bottom line is profit. So whether or not we're going through and doing testing, or we put physical controls in place, maybe we're doing network segregation or perimeter security, anything dealing with controlling computers or work area separations on the physical side of the house, these are all things that need to be looked into, as well as, but not isolated to, on the technical controls, maybe cabling and switching, where are those network closets at, different control zones and VLANs. And these are all things that really identity and access management help to identify, but also make sure that the CIA triad is continually kept as we go through and turn on some of these more sophisticated components to help us manage identities. And so there's a lot of different things that we need to become aware of. And we're going to be talking about some of those, like the multi-factor authentication. Sometimes you hear people say two-factor authentication. We'll talk about accountability and auditing and how important that is. Being able to break down sessions and make sure that they're not alive after a given period of time. Also, we talked about an enrollment component last domain with security engineering, the registration of those identities and proving those identities. Here's a key word right here that's kind of Star Trekian in nature, the federated identity management, as well as any credentials that are associated. And so we'll begin the discussion here with identity management. And this is something I've been involved with for a very long time. And it's a holistic approach to being able to allow people to identify, let me just type this in here, identify, authenticate, and authorize through automation. It gives us a way that we can go and do account management. We can have access control. We can reset passwords. But one of the key components here is this single sign-on. And that is something that's really, really cool. Once we go on and we're provisioning people's accounts, we can actually now go in and manage rights as well through this provisioning process. And the provisioning is essentially adding access to someone's identity. And I guess, conversely there, removing access would be deprovisioning. But all the while, we want to make sure that we keep the honest people honest and we audit everything that happens to people's identities. One metaphor that sometimes you hear is, if you had, let's just say here, that if you had, let's see if I can do all that. I probably can't, but whatever. If I had this big old elephant right here, right? So I have this elephant right here, and the elephant here is, we'll call him IDM. From an outside looking in, being able to try to figure out how we can eat this elephant, this identity management solution. It is such a big component of a large enterprise. Now we can look at it from an object perspective where this is an ear, this is an eye, that's a trunk, those sorts of things. It's a tail, right? But the question would be is that you can't implement everything all at once. So, metaphorically, sometimes you hear people say, how do you eat an elephant? Well, you eat it one piece at a time. And so how do you implement identity management? You do it one piece at a time. Because, the sum of the whole is fantastic, but until you get there, it's going to take you a long, long time. And so I say that because it all starts with what's called a directory server or directory services, okay? And so with directory services and directory servers, it talks over what's called an X500 schema. So this X500 schema is what typically is referred to as the directory information tree, or the DIT for short, right? DIT, directory information tree. And it's hierarchical in nature. So we'll talk about that here on the next slide, but you interact with the X500 schema, the directory, how it's organized. That's essentially what it is. It's the schema, or the organization of the directory. The way that this was explained to me over 20 years ago when I first got into business, which I didn't know that I'd make a career out of identity management, the way that this was brought to me was the directory in a business is oftentimes like the old-fashioned white pages. You have the yellow pages, which is a bunch of businesses and advertisements and stuff. That's not what I'm talking about. I'm talking about the white pages, which essentially goes from A to Z with every phone number and address of every person in your area code. Anybody know what I'm talking about? Put it in the chat if you know what a white page is. What white pages are. Yep. So if you take a look at that CISSP book, yeah, that's it, Brandon. Yep, the white page. Essentially, it's the phone book, right? And you take a look at that. I've actually seen somebody rip a phone book, which was kind of neat. I didn't think he could do it, but he did it. That white pages is really the one-stop shop for any phone number within my area code. And in that metaphor, what we do is, with our eyes, we read, it's indexed based off of, alphabet. So if, let's say I want to find um, Doug Homan, what I would do is I'd turn it to the H's. I'd look down at Homan, and if there's a Doug in there, I can probably deduce that boom, that's probably him. If I want to find Jennifer White, I'd go down there. I'd look for Jennifer White, and if I find her, then maybe there's two of them. I can call both of them, see if I can get her number. Uh, and I remember, the back for me, uh, if there were some pretty girls when I was in middle school, what I would do is I would take out the phone book, and I would look up their last name, and if it was an uncommon last name, I was in luck, right? If it was a common last name, then I had some dialing to do. But whatever, right? So I don't even know when the last time I've got a white page is. But we would look through them and be able to find based off the index of the alphabet. And this is the schema. This X500 directory information tree is a parent-child here relationship where it's hierarchical, and I'm going to show that here in a second. But it's organized in a way that allows us to do what's called an LDAP lookup. So what that means is that it's a lightweight directory access protocol. So what we do is we typically will talk to the directory server over an LDAP query. And so the query is basically you're telling the directory, give me Ben's information, right? And depending on whether or not I'm allowed to see that information or not, I either get it or I don't. And so underneath here, fundamentally, there's quite a few directory servers that are out there. One of the first ones that came on the market was Novell and NetWare. They had this thing that was called NDS. And there's, a few others here, but this is very simple. This is very simple, right? Novell has fallen by the wayside, and just about every other directory server has as well. So this is all I'm going to do right here, and I leave this on here to do this because 90% of corporations in the world use Microsoft Active Directory. 90%. And so what does that mean? That means that you have to buy a Windows Server license, not Windows 10, right? It's the Windows Server license, and that's probably like $1,200, or I don't even know how much it is because we get it for free being a Microsoft Gold partner. But the Windows Server license, you can add on the Active Directory service to create a directory. And this is kind of neat if you've never done this before, or if you've ever done this before, because it really essentially gives you quite a few things, including but not limited to a directory server. But what ends up happening is if you come and, you know what I want to do? I'm going to draw that in the color. If I create an Active Directory, then I can manage identities. I can, not in addition to that, I can manage computers and devices. And fundamentally here, the most important thing that I'm saying throughout the week, fundamentally right here, with Active Directory, you create this way, this service that's running, and it will run your domain. And this is one of the main reasons why Microsoft has been so successful, is because in right around 2000 timeframe, Microsoft came up with what they called the new technology. I think I mentioned this the other day. They called it the new technology, probably for like the first year that it came out. And then after that, it just became NT. And so with this new technology, they gave corporations the ability to make a domain. And inside of that domain, they gave you this thing that was called Active Directory, because the directory was a way for us to organize information, to manage identities, to manage computers and devices in a way that it provides unmatched lookups for authentication and authorization. Right? Unmatched lookups for authentication and authorization. Well, I already said that it does something else up here, right? It manages the identity. So if we just kind of look at, hey, that four-headed monster, remember I mentioned identities, authentication, and authorization before IAAA? Well, in addition to that, it also will audit everything that happens for accountability as well. And so this Active Directory runs on a Windows server, allows you to create a domain and interact with the domain, to control devices on the domain, to control the network on the domain. It allows you the four-headed monster here, the IAAA, and really is literally the most important thing within a corporate environment. And you may agree or disagree with me, but we're going to keep on going. I'm going to show you here what I'm talking about. So with your directory hierarchy here, so once you create that directory, this Active Directory, and on your exam, I doubt they're going to mention anything about Active Directory, right? Because that's a Microsoft product. Usually ISC squared stays away from specific products. So you'll hear them talk about, directory hierarchy, directory services, those kind of things. But they probably won't mention Microsoft because they don't want to throw them any bones or anything. But this directory server has this hierarchy that is, like I was saying before, it's a parent-child relationship here. Sometimes you hear people say that it's the hierarchical, right? Say that 10 times in a row. Hierarchical in nature. And this is kind of neat if you've never seen it before. Let's say that your schema here, which is a fancy word for the way that it's organized, right? The organized is the schema. Our schema here for directories is x.500. A lot of people just say x500. And so that schema is this right here, this parent-child relationship, where up at the domain here, right, you create the domain, and then underneath that domain, you have it organized into a few different things here. One of the things is called an organizational unit, or an OU, not to be confused with Oklahoma University. And so this OU allows us to organize things for lickety-split lookups, like I was just saying before, in a hierarchical manner. And so, if we wanted to traverse this directory that is managing our domain, we could go to country equals US, the OU equals US government, OU equals DOD, OU equals Navy, OU equals location, and OU equals whatever that is, OU equals that, O equals that, and then this is the actual person that we're looking for. And so what we would do is, if that person has a computer, let's say this person has a laptop right here, right? This laptop that's maybe running Windows 10 professional, right? They make you spend the extra $100 to get the professional version. So it's running Windows 10 professional. Let's say Kathy Conlon here, K Conlon, puts in her NT login, because that's what it's called, an NT login. She puts it in, she authenticates with a password, right? So she authenticates to the device. Well, what ends up happening is, if this is part of the domain, if this Windows machine is part of the domain, it actually, before it authenticates, what it'll do is it will come out to the directory server, and the glue between the Windows 10 professional machine and the Active Directory domain controller here is that this computer has joined the domain. It's joined the domain, so it's part of the domain. So the domain can control that machine and allow people to log on to it. It can pass group policies, or GPOs, down to it, group policies, which are essentially ways to lock down the machine, like number of password attempts, or maybe certain settings on the Windows firewall, or whatever those are. And those are all controlled inside of these organizational units that, maybe if you're in the Navy here, you have another OU here that is users and computers. And then underneath it here, you may have another OU that is GPO. And then underneath that, you could have another OU that is something else, and then policies that are built in there for quick lookup. But when this lady comes, and Kathy Conlon here comes and puts in her user ID and password, this machine will go out to the directory server, traverse the directory server all the way down to her unique object that's in there, and look at that object to do what's called a one-to-one verification. Now, what does that mean? Well, that's just a fancy way to say it does a match, right? So it takes the password, the user ID and password that you supplied, and it lickety-split will go down and do a lookup on that object in the directory, and it'll do this match to see if, hey, what was provided here, the password that was provided, is that the password that we have on file? And if so, then let's authenticate. And then it would shoot the message back saying a 1 or a 0, 1 meaning authenticated, 0 meaning nope, so sorry. And then it would either authenticate or say try again. And because of that, this technology is very widely accepted throughout the world. So these passwords are typically stored in an NTLM format on the directory server or Active Directory domain controller. So I'm going to write that in here, NTLM and NTLM. That's the format, the proprietary format from Microsoft. But these organizational units come in very handy. And typically, each independent user will have their own object, and that object will be called what is called a distinguished name, which is a DN. And essentially, that's a fancy way to say it's unique. And if you just kind of take a look here, as we would go through and take the, build out this LDAP query here that I would be passing from this machine to the directory, that LDAP query here, remember I mentioned that before, is typically something that you don't even need to do anything with, right? Unless you're a network administrator. You won't ever have to write a LDAP query, whether it's in PowerShell or Python or whatever programming language you like, even command line. But if you did, the LDAP query would basically say, hey, give me all the information at C equals US, comma, O equals US government, comma, O equals DOD, comma, OU equals Navy, comma, OU equals locations, comma, OU equals WNY, comma, OU equals NCTSW, comma, OU equals general. And then down here, instead of it just being an OU here, this would be the distinguished name, right? Down here. And then that means that this object for Kathy Conlon is the unique value for her on my network. So then associated with that, here we go, right? Associated with that, I would start to build out metadata. And now that we've talked about that, you should know what that is. And then that metadata would have the DN, like if she had, let's say, 2 computers and a mobile device that we provided her, we would associate those computers with Kathy Conlon's DN through metadata. So the data about data from her object to another object within there points to it, or essentially links the two together. It points or links the two together. And so if I do a lookup on Kathy Conlon, I will not only see everything inside of her user object here, but then it'll also say, hey, there's metadata that I have on file. You want to click on this? Yep, I'll click on that. I'll see all the computers that she has. If she has more than one user ID, I'll see all the different user IDs. Maybe she's an admin. She has admin K Conlon and just regular user K Conlon. If there's specific GPOs or group policy objects for security that are assigned to her users, there'll be another metadata link here. And really, what ends up happening is this one object right here, this one object for Kathy Conlon has data about data about data about data, and essentially very, very quickly, very, 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 very quickly, we can get deep in the bowels of this identity management solution, this directory server, Active Directory, and pull back every data element that we have on this one user. Lickety split. Lickety split. It is unmatched as far as trying to go pound for pound against database servers, other types of tree technology. The Active Directory still is the number one for the IAAA, for managing that all in one place. And so it's a parent-child in a hierarchical manner that is this right here. You know, it goes down, it looks it up, brings it back. It has these things, the way that it's schema, that it's organized into these OUs. And each individual person has what's called a distinguished name inside of it. So that's a lot to take in. Any questions? No questions. All right, so I want to show you something here. And please, if you don't pay attention to me, um, I guess I'm okay with that. But you know, I'm hopeful that you will right now, because this is perhaps where I kind of tie it all together. So check this out right here. I know I'm doing something, and I'm going to share it with you right now. Hold on. So if I take this right here, okay, I'm going to take that, and let me do this first. Let me do. How do I want to do that? I want to do this right here. Yeah. So if I take this, and then I'm going to do that. Just give me a second. I'm building it over here for you. All right, so if there's no questions, then that is the best news that I've heard all day. So if I take that drawing that I just did, okay, and I put together another slide. And that other slide is like this right here. And then I share it. So check this out. So what I just drew here, just to make sure that, you know, there's nothing up my sleeve, this is what I just drew, right? And this is it over here. This is what I just drew over on this side, right? What I did is I made a carbon copy and put them right next to each other, because I want to show you something here. And this is perhaps the most important thing that I'm going to show you throughout the week. Check this out. If I do one thing here, I do one thing, and that is, let me do that color. If I do this right here, and I say, type in the chat window what that is. This right here, what is that? Boom, Ryan. Boom, Alicia. Boom, Jennifer. But Alicia and Jennifer, it's up one level from that. Yes, you're right with that, right? That is correct. Yes, Doug. Yes. The spelling there's a little whack though, Doug. But whatever. I understood what you meant. So the point here, yeah, I know. The point here that I'm trying to make is that not only here does Microsoft own Active Directory, but they also have a PKCS, a public key cryptographic service add-on to Windows Server that allows you to set up a certificate authority. And by setting up that certificate authority, you can then create the certificates in the X509 format. But look at the way that this is organized here, right? Because the only thing that I changed was up top there, right? So check it out. The way that this is organized is I would stand up the primary domain controller with Active Directory, similarly to what I have over on the left-hand side. And then I would stand up a certificate authority for PKCS, Public Key Cryptographic Services, that stores these certificates. But look at the hierarchy here. So instead of me over here, in this Kathy Conlon over here, I'd have first name, I'd have last name, I'd have, all the other descriptive stuff about her over here. Well, then over on this side, over on this in the certificate authority, it still is organized the exact same way through a directory server. And it allows me to now, you guessed it, I can link these two right here. I can link the identity from the identity management server, the Active Directory, to the certificate authority directory server using, you guessed it, metadata tags. And the metadata tags would essentially be over here. I say, hey, yo, there's a pointer over to that other server. Now, before, you see how before I was saying in different organizational units, there would be other things in these different, like, the computers, the group policies, printers, those sorts of things. Those would be on this Active Directory server right here, right? But you see how I have it logically separated here, right? So there is a boundary in between these two. Why did I draw it like that? And why is that best practice right there? Put it in the chat. Why do you think that's best practice? Yeah, that's correct. That's correct, Ryan. Yeah, absolutely. Separation of directory duty. Yeah, I like that. I think we should trademark that word. Well, literally, this is how we can encrypt and digitally sign stuff. Right? That's how we can encrypt and digitally sign. And literally, this server over here is literally the keys to the kingdom. And so what we do not want to do is we don't want to give people that have access to anything over here, we don't want to give them also any commingling here. We enforce separation of duties, but also because this is typically, these keys to the kingdom are typically in the DoD, it calls it, it's a standard form 85, and that is a position of public trust, is what that is called. Why? Why is that so important? And why do you have to go through a separate background investigation? What's called a position of public trust. What do you think? Yeah. Not only PII, because you have access to PII, but literally, if you are the administrator here, like if you have administrative access to this one or this one, um, I could take keys from anybody and either get them out of escrow or um, look at the key pair inside for this object, right? And I could potentially spoof or pretend like I'm sending an email from somebody. So that's why this typically is a position of public trust over here, usually. So that's a big deal. That's a big deal. Not only because it kind of puts the glue for the different components that we've been talking about here with PKI, the certificate authority, but also, the directory server and kind of mind melds them together and tightly couples them, But not everybody can afford PKI. Not everybody can afford PKI, but a lot of businesses want to be able to control their network, and you control your network using a directory. And the number one used in the world for the past 20 years is Active Directory. It's Active Directory. So why? Why is that so important? Well, we want to know the identification and basically who's connecting, but the user ID. But also, we want to be able to check one way or another. Usually, best practice is to have at least 2 factors of authentication, right? And so, you can use static, something dynamic, like a token or secure ID that's, synchronous every 60 seconds or so. Biometrics, maybe your butt print. I mean, we gotta have a little bit of fun there, right? Whatever. Or some of these types of remote servers, like the Challenge Handshake Authentication Protocol, or the Radius server that's used in ISPs like Verizon and AT&T, or maybe even if you have some VPN with Cisco, TACAX, could be something as well. Or you could be using PAP. Those are all things that we use to authenticate people. But right off the get-go here, we need to know that you will see a question on your exam on 2-factor authentication, 2FA, and usually people say something a person has or something a person is. Any 2 of these is considered strong authentication. Any 2. Okay. Another way to look at this is something that a person can forget, something a person can lose, or something a person can get cut off. So knows, has, or is, or forget, lose, or cut off. I know that's kind of extreme down there, but people typically will remember it if we take extreme measures, right? All right, any questions on that before we move to the next episode here? All right, let's keep on trucking. So I throw this in here because I'm kind of silly, but in programming, the exclamation point, or as a lot of programmers say, the bang here. So bang equals, right? That usually, these 2 together means what is not an identity. That is the best question. I put here, what is an identity? Well, really, the better question is, what is not an identity? check it out. Think about if you did something today. Like, where did you go? How long have you been around? What have you been doing? Well, you probably, woke up at your normal routine of, 0500. You went out and you ran 10 miles, but, the first thing that you're going to probably do is your phone is probably going to wake you up. Maybe you have a phone alarm. You hop in the shower. You get your sneakers on or whatever you're going to go do. But we have a way that we have full traceability for everything that we do through the IAAA on for digital evidence. So, a lot of times when people commit crimes nowadays, especially with location settings turned on, we can find out when did you log into your computer, when did you check email, when did you first use your cell phone, when did you buy gas, when did you buy food, did you sext or text someone? Because if you were driving and you're texting while driving and you end up T-boning somebody and something bad happens, were you texting while driving? Well, you know what? We can figure that out. We can subpoena your phone records and we can find that out. But also, we can look and see what somebody did. Did they pay? What time did they pay? How much did they pay? What bank account did they pay at? So the evidence is there to support what you did or did not do based off of anything electronic, especially with the rocket in your pocket, your cell phone, right? We can look at location data. We can, track via Google Maps where you've been all day long, and those types of things. And I say that because sometimes people like to give you false alibi, and if they do, then how are you going to convince somebody that you were at a different location at a certain time? Well, it might be very difficult in this day and age, especially if you have a cell phone. Now, a couple things remain true. One is that concept right there. Cash is still king, right? And it's kind of interesting. I stopped by a store last week, and it was a newer store here in Madison, and I get up to the counter and I'm getting ready to pay, and the person says, "Can I have your phone number?" And I have cash. I had cash, and I kind of look at them. I was like, "Well, I'm going to be paying with cash." And they said, "Well, our computer won't let us take your payment unless I put your phone number in." And I kind of look at them and I'm like, "Come on, I got cash." And the lady, she looks at me and she was kind of, and I just look at her like, we don't got to make this awkward. I got cash. Do you want the money or not? And whether or not you choose to pay cash for things or not, that's up to you. But a lot of times that's what I do, not only to stay out of debt, but also, maybe I don't want people knowing where I'm at all the time, right? But cash is king. Well, let me give you an example of being able to track certain things. So, I have kids that are in the Madison City School District here, and my son, we have we got him a cell phone, and he was so excited when he got his first cell phone. He was super excited, and he really tried his hardest to make sure that he knew where his phone was, and uh, well, a little while ago, he uh, he was we were at a Halloween thing. It wasn't this year. It was last year. Let me see if I can bring that up. Was it last year? I don't even remember when it was now. Let's see. Nope, that's not it. So he's looking for his. We're at this Halloween thing, and he ends up figuring out that I guess he put his cell phone down on a bench, and when he put the cell phone down on the bench, apparently the cell phone got some legs and started to walk away, and it was quite unfortunate. So me being the dork that I am, okay, so it was 3 years ago that it happened. Let me bring it up over here. So I sent an email to the principal here, and I said, Mr. Richardson, could you assist me with getting Max, my son, the phone back from whoever took it home last night from or the festival Thursday night. So that was whenever it was, and I guess I sent it on Halloween. We'd like to give whoever took it a chance to return it with no questions asked before we call the police. Now, how did I know that? Well, I had a pretty good feeling that it just didn't get legs and walk up on its own because I did have geolocation turned on. So what I told him is I used geolocation data from Google Android's timeline. That's right, I did, to trace the phone the night it was lost. So check it out. When it was lost here, we were at the elementary school at 6:05 until 7:29. And I said, whoever took the phone away, walked away from Horizon at 7:29 p.m. and traveled to Magnolia Point Apartments, which is right across the street, and arrived there at 7:47. And so I said, here's a GPS tracker of Magnolia Point Apartments. So it looks like whoever it was, went to a couple locations over there, and I pointed those out. I said, specific destination of interest appears to be one of the apartments in the back. And I think it was this one right here. That little circle looks like it's distorted here on the screen, but it was like right here. So whenever I went there to do or to show them that, it kept doing it. And I said the person who took the phone, or perhaps their parent, appears to have taken the phone in the car in a total travel time of 20 minutes. So they had it. Looks like they used GPS to track it, and they went over by the Pizza Hut on Madison Boulevard that night to a barbershop. And I went and I took my black Suburban right in front of the barbershop the next day. And I actually walked in there and asked around if anybody had seen a cell phone over here. So that's what the barbershop looks like. And then whoever took the phone went from that barbershop over to the shopping plaza across from Madison Police Station on Hughes Road. And there's a barbershop over there called Creative Clips. That's what Creative Clips looks like. I also walked over there. And then they went back to the apartment complex. And then the phone battery died at 7:47. And I said, before I contact the police to help me get the phone back, again, talking about identity and traceability or accountability, I want to get phone back. I want to ask if you can figure out which students live in that building and ask them if they have the phone. Hopefully the child innocently picked up the phone and return it once you ask them. Please let me know if you can help or if we should contact the police first. So that's just me kind of showing that I did my due diligence, right? Throwing the warning shot across the bow, ready to come in like a bull in a china shop. So here we are at on it looks like Halloween on 2017 at 12:13 in the afternoon, right? That's when I sent that email to the principal of the school. Check this out. Uh-oh. Where's the reply to this? So 12/17. Let me see if I can get the email. So I'm just trying to give you a timeline here. Oh, here it is right here. So Mr. Richardson at 12/17. Mr. Richardson replies back to me at 1:49 right there. 1:49, which is what, an hour and 32 minutes afterwards. Right? I have the phone. So, not only can, we use it to, find out what's going on, not only from a, time and location perspective, right? Uh, but you can also track it. We can figure out where it was, when it was there. If somebody's lying, we could also keep them honest by trust but verify, and that's something that is quite interesting. Uh, I'd love to talk more about that, but any questions on anything dealing with the identity directory server or anything along those lines before we jump into talking about biometrics? I want to make sure that I talk about biometrics and then jump into the different types of access control. Any questions before we take a quick break? Okay. Well, we're going to take a quick commercial break, and let's make it how about a 10-minute break? So we'll come back at 1:55. Come on back at 1:55, and we'll see you soon. All right, welcome back. Let's go ahead and get the party going again. So when we jump in and continue our discussions on the components that make up identity and access management, one of those is biometrics. And this is really a continual growing field. And there's some really neat technology that keeps advancing. So if you're interested in this as a pocket of something that you may want to specialize in, there's plenty of room out there for new inventions, but also just new ideas and technologies. So with biometrics, we have the three different types of errors here. I'm going to put something into the chat window with the intent that hopefully this will help, but there's a great chance that you will see something along the lines of a type 1 error, a type 2 error, or the crossover error rate on the exam. And why do I mention that? Well, because, let me type this in here real quick. Okay, let's crossover error rate. Let's see, we are. Trying to find a page real quick. So when we jump in and talk about any type of authentication, something the person is, immediately you start getting into a little bit more, some people think a little bit more invasion of privacy. There's a bunch of different types of biometrics that are out there. And I think there's some on the next slide. Yeah, there's fingerprints, palm scans, all sorts of great, cool things that are on there. And usually, we will see one on the retina, which is the blood vessels in the back of the eye. Maybe one on keyboard dynamics and one on fingerprints as well. Some people think that it's an invasion of privacy, especially some of these more intrusive ones, because you can tell a lot of different things that are going on about a person, especially with like a retina scan. Like looking at the blood vessels, you can tell if somebody has diabetes. Other ailments. But also, if a woman is in menstruation, you can tell that as well, apparently. So a lot of these are kind of neat, and if you've never, pregnancy as well, yeah, absolutely. With biometrics, it's very difficult to impersonate. There's a pretty cool movie that I remember seeing a long time ago with Uma Thurman and Ethan Hawke called Gattaca. And that movie, Well, thank you. Thank you. Amos, would you do retina scans, or would you like look in the person's eye? Okay. Yeah, so when we talk about biometrics, okay, how that authenticates, let's say we're dealing with the fingerprint, right? So we got a fingerprint here, and going to that one-to-one verification that I mentioned before, or the match, right? How does that look? Well, if I have your fingerprint that you're trying to authenticate to a system, and I have this one on file, uh, if the system rejects an authorized individual, it's called a false rejection. So this is an authorized individual, right? So authorized individual is rejected. Now, that could be a little annoying, right? If an authorized individual is rejected, but that's a type 1 error. And it's also known as the FRR. Sometimes on the exam, they'll ask about a type 1 error, or they'll say FRR instead, they'll abbreviate it. So when the system accepts an imposter who should be rejected, that's a type 2 error or a FAR. And let me just say accepts an imposter. And the type 2 error is a deal breaker, right? Think about that. If you're getting ready to buy a biometric system, and there is one FAR, false acceptance rate, where it allows somebody to authenticate that's an imposter, that's a big deal. Well, when you're going through and looking at these different systems, when people are going through and looking at biometric systems, the goal is to try to obtain low numbers for each type of error. And in the book, it says type 2 errors are most dangerous and the most important to avoid. So typically it looks like this right here. If you just put a little graph together, this graph constitutes the crossover error rate. Or CER. And that CER is important because that's how we're going to evaluate the system. But really, this is a percentage that represents which point the false rejection rate equals the false acceptance rate. So if the accuracy of a system is ever in question, if let's say I have a crossover error rate where here is the false acceptance rate, and here's the false rejection rate right here. If let's say this value is 3 for one system, and then we look at another, we're evaluating another system that does biometrics, and it has a 4. The lower the system, the better, because that means that it would have less false acceptance rates. So lower is better for the crossover error rate. okay, you will see a question on your exam on one of these three terms right here. And they may ask it type 1, type 2, type 3, or they may say, false rejection rate, FRR. They may say FAR, or, false acceptance rate, or they may say just CER. Oh, really? That's cool. Oh, no, that would suck for your chief. Thanks for sharing that, man. How long were you paramedic for? 20 years. Holy cow. I bet you got some stories. That's pretty cool. So that's really biometrics. And, it is super important for us to make sure that whenever if we're evaluating a biometric system, that there's no false acceptance rates, or as little as possible, And so, why is that important? Well, because it really is something that keeps evolving. People are coming up with really neat technologies, and even the phones that we have now are using biometrics, which is kind of cool. So there's some cool things that the different passwords that are out there, security issues, and different best practices that are in there. But one of the cool things that Active Directory does for us is it gives us the ability to have a single sign-on, right? Active Directory single sign-on, and that's why it is so revolutionary, or maybe not revolutionary, but anymore. But when it came out, it was just like the coolest thing, because people didn't want to have to remember a password for this, that, and the other thing. It gives you the ability to have password synchronization. You can extend a self-service password reset, or do anything with assisted password resets. And these two are kind of interesting, because this really, if you implement self-service or an assisted password reset, then that reduces labor cost for the help desk, because that's the number one thing that the help desk will get, is phone calls to try to reset passwords. And so, being able to manage those credentials, those accounts, really come in quite handy, especially from a single pane of glass like within Active Directory. But I would encourage you to go out and read more about it, because maybe there's other technologies that I'm not telling you about. But like I said, 90% of the world, corporations in the world, use Active Directory. So at the guts, behind the scenes of Active Directory, there's this thing called Kerberos. And Kerberos, you may remember from Greek mythology, is the three-headed gatekeeper to the Greek underworld. Right? Well, Kerberos is built in to Active Directory. And it manages, this is probably one of the most important things, Kerberos manages single sign-on. I'm going to write that real big, right? But for purposes of your exam, you could have anywhere from 2 to 4 questions on this one topic right here. And it's kind of interesting if you've never taken a look at it. It has this thing that is called, and again, this happens it's built in, so it happens all behind the scenes. It has this thing called the Key Distribution Center. And the Key Distribution Center has all these different things that are called keys that it distributes for anybody that it's authenticated to the system, or anybody or any service that it's authenticated. And because of that, it allows, if you join a system that's using Kerberos, it provides you integrity, and the trust of that is really the crutch of how Kerberos works. So there are certain objects that are called principles that like computers, maybe printers, network file shares, and the like, that can be qualified as an object. And then there's these access tickets here. And that's the number one thing that usually we see on the exam when talking about Kerberos is tickets, tickets, tickets. So anytime you hear the word ticket, we're not talking about a Republican or a Democratic ticket. We're talking about these access control tickets, and typically these are temporal. These tickets typically will give you access to something for usually 10 minutes. So, with time, temporal, 10 minutes. And after that 10 minutes of, if there's inactivity for 10 minutes or longer, it'll automatically log you out. It'll log, let me write that, log out, right? And I'm sure you guys have seen that before, that, if you do things on the system, it'll keep it alive. Periods of inactivity, it'll automatically log you out. And what it does is, when you authenticate to the Active Directory, built inside of it, it'll have this key distribution center that will assign you access based off of what you're authorized to see, and it grants you these. They're abstract concept here, but a virtual ticket behind the scenes that's only good for a certain amount of time. And then, if you have a period of inactivity, you would go and do it all over again. So you log back in, you provide the credentials, you have that one-to-one match. And so, this is a security technology that gives us authentication functionality with the purpose of protecting any company's assets that are out there. It was first brought in with in MIT back in the 80s, and then Microsoft hired off a couple of those geniuses to come and work for them. And it gives you a great range of security capabilities, flexibility, scalability, and really the main components are the key distribution center, the different principles that are out there that could be users, it could be applications, it could be network services, different objects that are on the network. And then the ticket is granted with access to something. And that ticket that's granted, this is the last thing here, the ticket that's granted is granted from what's called a TGS, the Ticket Granting Service. Or TGS. And that TGS is super important because it is the one that literally will give the tickets out. And then once you have the ticket, you can print on the print server, or maybe have access to the realm. That's what they call it, the realm, or the web of trust. And so really, this is a really neat technology that happens behind the scene. The authentication happens behind the scenes. And you may be familiar with this from Security Plus, because I think that this was also on the Security Plus exam. Kerberos. All right, let's keep on going here. These next components here, I want to make sure that we cover these. Discretionary access control, rule-based access control, role-based access control, and mandatory access control. These are kind of cool. Oh, here we go. We got a question. Sequence ticket granting. That's a great question. Are they going to ask the sequence of ticket granting? No, I don't think so. Usually it's not that granular. Some test banks out there may have test questions that say that, but usually that context clue, whether it's the key distribution center or the ticket granting service, authentication mechanism, single sign-on, those are typically the words that we see associated with questions that are from Kerberos. Hope that helps. All right, so let's keep on trucking here. I want to make sure that I have time to go over some practice questions. And I'm almost where I need to be right now, so. All right, so discretionary access control is typically the most common. These are the four main types of access control. So this is the most common. And usually when we have a computer, usually we're dealing with the DAC model. So Windows, Linux, MacBooks, you have full control of your computer. Okay? So if you have full control of the computer, then it is at your discretion. If it's at your discretion, then that means that you can assign people access to certain elements, but also you have full control, right? So it's at your discretion. You can assign access to things. You can assign access to people. So it's in your control. You have full control, right? Whereas mandatory access control, this is, the control is mandated to you. So control is out of your hands. Usually the control is put on the system. So the system has control, not you. Not you. And so, if you were looking to go in and do certain things on the computer, it's very likely that it would be locked down completely. And if it's locked down completely, there's not much you can do with it, right? Not much you can do with it. Now, let me give you a perfect example. For any of you guys working in the DoD world, this is typically, what your out-of-the-box DoD operating system will be. So you basically have a glorified email system, right? Because you really can't do anything. It is not at your discretion. And operating system or it reduces the amount of rights that you have. Okay. So because of that, it's mandated to you. You have no control. Whereas discretionary, it's at your discretion. And that's the main difference between those two. I'd be surprised if you didn't have one on each one of these. So 4 questions overall. I'd be surprised if you didn't have 4 questions on these. At least 4 questions on just these terms right here. So rule-based access control, these are logic-driven and typically involve an if, then, else statement. So typically rule-based access control are on places like firewalls, access control lists, maybe intrusion detection systems where, they do alerts. Basically, you're setting up a rule, it's logic driven. If it goes to, if I see something that looks like this, then send an email. So that's typically what we see for rule-based is, for firewalls, access control, and intrusion detection systems. Whereas role-based typically is for provisioning access to groups of people. So you may have seen this before. If you're putting in an access control request, maybe you say, mirror access to somebody. Well, typically that mirror access has on the back end these different job functions that somebody needs, right? And these job functions could be from different departments or maybe different roles within the organization. And so if somebody, let's say, is enforcing RBAC, we may say, let's give them the IT role, which gives them access to, Active Directory. We may say, hey, give them the HR role and maybe give them the admin role. And based off of that, now this person has 3 roles that are assigned. Each one of these roles have already been set up that, this role would give you access carte blanche to, these different applications and these different functions. Okay, so that's the primary difference between these 4. And I'd be surprised if you didn't see each one of those on the exam. Any questions? All right, good. All right, so I want to talk a little bit about accountability, and then we'll jump into intrusion detection, and then I'll wrap it up and do a little recap here. So with accountability, that's directly related to, or directly correlated back to, with accountability, it's directly related to auditing and being able to have the audit documentation and any log files that are associated with that. So any type of recording that's done through audit functions needs mechanisms within an operating system or an application to allow that to happen. So audit trails typically usually will contain information about the operating system, any activities that are done on that operating system, the applications, any events that happen with those applications, and any user actions. So typically built into an operating system is a syslog server. And that syslog server usually can be, you can view that through something like the event viewer on a Windows machine. And what we do is with the syslog server, we will send those syslog files out to a log aggregator, like a security incident and event management system, or SIEM, to be able to see, why a system crashed, or check the health or the performance of, certain systems. And audit trails can also be used to provide any alerts about suspicious activities that we maybe want to go back and investigate at a later time. And not only that, but we can hopefully have a way that we can determine exactly how far an attack has gone and the extent of the damage that it may have caused. And it's important to maintain that proper chain of custody. I know that for a couple of attacks that we've had, that we've helped with post facto, we have gone into the event viewer and looked up some of the events that have happened to see, the time of day or the time of use or time of day that something may have happened. And usually there's an event where it'll trigger some sort of, error message. And in that regard, you have the traceability back to accurately represent that trail in case it needs to be used for later events like any criminal proceedings or investigations. And it's a good idea for us to try to, keep that in mind whenever we're dealing with anything in the audit world. We want to store the audits securely, make sure they can't be updated. We want to make sure we have the right tools to keep the size of the log files under control. That's a big deal. The size of the log in this particular case, that does matter. The logs also need to be protected to make sure that any changes to it are under configuration management or not allow changes at all. And then we got to have the right people on staff, right? We got to have those people to review that data and correlate it and make sure that in that highly privileged environment that nobody's doing anything nefarious. So usually those log files and the accountability components are tightly coupled with intrusion detection systems. And those will help with prevention or mitigating any type of access control attacks or bad things happening on systems. So the IDS typically will look for something suspicious on the network or on, if it's a host-based IDS, on the host, and then make an alert by sending out an email or maybe sending a text message to say that something's changed. And based off of that, we want to make sure that with these IDSs, you can also use the type 1 and type 2 that we talked about for biometrics earlier. One is a false positive and one is a false negative. So you can bucket them in to a certain false positive or false negative, and based off of the false negatives and false positives, then the idea of this intrusion detection system uh, really comes in handy. This is a pretty interesting thing. If we know of a signature on something, what we can do is we can try to detect based off of that signature. So detect events based off of the signature. Whether it is something that we know, or if we don't know, we can look for things out of the ordinary with the anomalies. And if it's out of the ordinary, if it looks like a duck, quacks like a duck, swims like a duck, it's a duck, right? And so if we know that it's out of the ordinary, we can make an event and log the event, send the notification out to somebody, or send the alarm or the alert out to someone, letting them know. This is kind of cool how these are set up. They can be set up in a network environment, and it's called a NID, or it can be set up on a host or a HIDS. If you're familiar with the DoD, actually something like HBSS might be a good example, the host-based security system of a HIDS. The NIDs are a little bit more difficult. Probably one of the most popular open source ones is Snort. Typically, with intrusion detection systems, let's say we have a network router right here, right? So it's capturing data at layer 3 of the OSI model. Let's say we have an 8-port router right here, an 8-port router. What I can do is I can take port 1, 2, 3, 4, 5, 6, 7, 8. I can take 1 through 7 and write a rule inside of the router to create port 8 as what's called a span port. And so that span port will copy all traffic that's going over 1, 2, 3, 4, 5, 6, 7. And then it'll, through the FPGA or the microcontroller on the back end, it'll push it out through number 8 right here. So we create this span port over number 8, which is essentially a mirror of all these other ones. And then we hook in the network cable into number 8 into usually an IDS as an appliance, or like a 1U server, rack mounted server, 1U rack mounted server of some kind of piece of hardware. It's a 1U rack mount. And then inside of here, inside the logic on this board, that's where you'll have a little web server that you can go in and play around with the interface, the signature base or the anomaly base. That's usually what we see with this, is that the intrusion detection systems are hooked into a network by taking an initial or a network appliance that is currently at usually the trunk of a network. So at a strategic location, we'll make one of the ports a mirror port or a span port, and then we'll send all the traffic from all the nodes or all the network, the NICs there, over to the new intrusion detection system. Now, these ain't cheap, right? These are super high end. They're super expensive. And not only are the appliances, the 1U rack mounted server, expensive, but the people. So if this is something that you want to get into, this is in high demand still. High demand. I figured out a long time ago that I didn't want to look at network traffic all day long. So that's not something that I enjoy doing personally. All right, so the last thing that we're going to jump into, and then we'll ask some questions, is the keywords that you may see here related to this domain. Provisioning. So this is to grant or create access for a user or an object. Usually nowadays, there's no longer the sneaker net where you fill out a paper form and you send it from point A to point B. Usually now provisioning is done via some sort of workflow mechanism, whether it's SharePoint or there's some really robust tools that are out there that will handle workflows. So keep that in mind. Provisioning means to grant or create access for somebody. Usually best practice nowadays is to try to automate as much as the provisioning as possible. Provisioning and deprovisioning. So that's kind of an important concept because usually you'll hear people mention that. An authoritative data source, we went through this before. An authoritative source, I'm not going to spend any time going through that again. Here is a concept that is for identity repositories. So if you have, let's say, company A, right, and then we have company B right here, and then we have company C. So we got 3 companies. Well, company A decides to want to start sending encrypted emails back and forth. What they can do is have fiduciary relationship here and share some of the key with company B. And together, what they can do is they can create this federation or federated identity. So between organizations, they can create this federated identity. And the same thing would go if both of these companies wanted to have a relationship with company C as well. They can have a fiduciary, a federated identity created. That means that, hey, maybe user over at company A, since these guys all trust each other, user at company A might be able to access a resource down at company C, and they don't have to sign in once here, and then once here, and then once here. They sign in once here, and then they're automatically provisioned, but also through single sign-on and federated identity, they're able to access that resource as well. We see this in corporations, but also a lot of times in DoD, the different branches and service. Your identity may be for the Army, and maybe the Marine Corps accepts your identity. So that would be, quote unquote, a federated identity in between those two. So you may see that come up on the exam. Now, there are some interesting things here that help with the life cycle. And one of them here is, and again, the life cycle. One of them is when we talk about federated identity, we also need to talk about open authentication, or OAuth. And that's where you use maybe your Google account to log into things. So basically, if you go out and you want to, let's say you want to create a Snapchat account today, with Snapchat, whenever you go on there and log in for the first time, it says, do you want to use your Google account? You say yes. And then what Snapchat does is basically transfers risk for authentication and authorization over to Google. So basically Google's handling the login for you. And what they do and how that happens behind the scene through open authentication is there is what's called a SAML request and a SPIML request. So the SAML request is this thing that's called a service assertion markup language. And the assertion here, really the thing to remember here is the word assertion. The assertion is that, hey, user wants to log into my website or my app. They're asserting that they have a Google account. Google, I'm going to pass something over to you, maybe their Google email address or Gmail address, and then Google asserts that, hey, yes, in fact, there's a one-to-one verification between the two. Go ahead and let them in. And so that's a SAML request. And the last one here is the service provisioning. Somebody had a question? No? Okay. The word provisioning here is the one to remember. So the P and the A are the most important assertion and provisioning. So provisioning means that, just like we said before, it's going to grant or maintain, create access, usually through a workflow. So maybe, in this example, Snapchat says, hey, we need to create somebody, but also we need to provision some access. What they can do is they can send it from one website to another and actually provision access in another website if there is a trust agreement between the two. So website A may trust website B may trust website A. So website A could actually say, hey, I'm going to send over a provisioning request. Can you go ahead and give this person additional access? And because the two trust each other, you can programmatically set it up to go ahead and provision that additional access accordingly. So there's a lot going on with this domain. One of my favorite, hopefully I did it justice. Any questions before I go back and start asking questions for a review here? Any questions? Yeah, okay, so we had a question come in, says the provision, they always think about that being like something that you're given in the military. Yeah, so provisioning really means that you can grant, maintain, and create access. Usually it's done programmatically through a workflow. Usually it's done programmatically through a workflow. So I'm going to put some questions into the chat here with the intent that you're going to know them. The first one, how apropos here, an automated, let me put this in here real quick. All right, so let's go ahead and what do you think for the answer there? An automated blank component is common in account management products that provide IDM solutions. Yes, Amos. Yes. I just said it, right? Maybe I should turn the TV on back here. Or handle the. All right, so an automated workflow. Yes, Doug, good. Automated workflow component is common in account management products that provide IDM solutions. So basically, we're trying to get away from the paper, the sneaker net, delivering a piece of paper from one desk to another to get a stamp and then go back and then create the access. So these workflows will go through and automatically provision the accounts for people. What about this one right here? User blank, and this is a word that I've said probably 15 times in the last hour, refers to creation, maintenance, deactivation, and use of user objects. Yes, Amos, good. Yes, Doug. Anybody else? Ryan? No, not that. Yes, Alicia, good. Provisioning is what we were looking for there. So user provisioning refers to creation, maintenance, and deactivation of user objects and attributes. So this is a good one here. The HR database is usually considered the blank data source. Yeah. Good. Authoritative. That's what we were looking for. Fantastic. All right, good. How about this one right here? I was looking for authoritative with the last one. What about this one? Okay, so this one, getting a lot of answers here. Okay, so this enables the data owners to dictate. So if you own the data, it's at your discretion. And this one is discretionary access control. Whereas this type of access control allows the systems to determine who controls access. So it's out of your control. Yeah. Amos, no. Jennifer, yes. Ryan, yes. Alicia, yes. Doug, yes. Brandon, yes. Oh, okay. Yeah, so for the last one, I was looking for mandatory access control. What about this one? This type of user access control is based on a user's role and responsibilities within. Yeah, Doug, good. Yeah, That's right. Good. And you'll always see that one on the exam as RBAC, role-based access control. Yeah, this type of access control is defined by adding Boolean logic in the form of rules or policies that further restrict access. Usually it's an if then else. That'll be a rule-based access control. Yes, good. All right, what about this provides the capabilities that can be accomplished through Kerberos domains and thin clients. Capabilities. Yes, Amos. Yes, Doug. Yes, Ryan. Jennifer, close. Close. That's why you have it. This is why you have a directory, is for this capability. Yes, Ryan. Good. All right. I was looking for single sign-on provides the capabilities that can be accomplished through Kerberos. Single sign-on. Okay. If I say that's funny. That's funny, Ryan. Yeah, I was looking for tickets, tickets, please, tickets. Uh, Kerberos, Kerberos. That's right. Okay, what about this one? Okay. Yep. Good, Ryan. Okay. Doesn't just have to be the certificate, right? Yeah. Amos, good. Doesn't necessarily just have to be a login, right? But yeah, impersonating someone somehow, whether you're able to guess it, whether you're able to be the man in the middle, but impersonating someone with the intent to do bad things, spoofing. Yep. We oftentimes see a spoofed email. Um, that's one of the biggest infractions there. All right, what about this right here? Remember I said strong authentication earlier? Strong authentication? Yeah, at least two of the three. Well, speaking of that, user authentication is accomplished by what? Yeah, that's right, Alicia. Good. So yeah, I was looking for user authentication is accomplished by what? Yeah, authentication, identification, proving an identity. Yeah, identity management. I was looking for something you know, something you have, something you are, but certainly those other ones uh, get us to where we need to be. Good. All right. A few more here, and then we'll take a quick break and then come back and jump into something else. Good. Boom. Boom. Ryan, good. Jennifer, good. Doug, yes. Alicia, no. We were looking for it's a portable identity that can be used amongst businesses. That's going to be a federated identity. We can do a little Star Trek for that, right? So this one's going to probably be this next one's going to be the hardest one. For 1 million points. Can you get it? Oh, just missed it, Ryan. Swing and a miss. Actually, you fouled it off. Yeah, there you go. Hit that one on the screw right there. Yes, Amos. Good. Yeah, Doug. Good. Take a guess. Take a guess, guys. Close, Jennifer. It's a component of OAuth. No, we were looking for that one. This is an XML-based framework that's developed by Oasis for changing user, resource, and service provisioning information between cooperating organizations. That's SPML, SPML, right? Service provisioning markup language. All right, what about this one right here? And I think this will be the last one that we do. That's right. Actually, I lied. That's not going to be the last one. I want to have a few more here. Yeah, so that one, I spent a lot of time on that. Yeah, Active Directory. Good. All right. I only sent that to Alicia. There you go. Here's the next one. Blank creep takes place when a user gains too much access rights and permissions over time. So think about slow creep. Oh, that sounds like a personal problem there. So if somebody changes job functions within an organization, and they will maybe be a system administrator over at one department, and then they are a system administrator over another department, and somebody doesn't delete what they have, this can happen. Yes, Ryan. Good. Yes, Brandon. Yes, Amos. Doug, close, but it's a different word, a little bit different word. Jennifer, no. I mean, yes, but no. It's yes. There you go, Doug. Jennifer, it's specific to identity management. It's blank creep. Yeah, that is another word for it. So yeah, what we were thinking there is that if you have one privilege at one job and then you go over to another job and you keep those same privileges and you keep all that, maybe it would be a slow creep. Somebody said that in there, but no, it would be an authorization creep. We're just going to go ahead and play a part of the song here. Because I'm a creep. It's authorization creep. Yeah, I'm a winner. Hopefully you're a Radiohead fan. If not, then you have no idea what I just played there. Anybody a Radiohead fan? Anybody know what I'm talking about? Okay. Thank you. Thank you. Thank you. All right. This one is tricky, and a couple of you already have answered this for other questions. But so this is an open standard that allows, and there's a context clue that I just read, allows a user to grant authority to some web resource like a contacts database or to the ninja of cyber. Oh, no, it doesn't say that. It says to a third party. Yes, Brandon, good. Alicia, good. Ryan, good. Yeah, Jennifer, good. Doug, great job. Amos, fantastic. Right there. Awesome. I love this domain. This is one of my favorite domains. So let me put this in here. These type of, this is a, we haven't covered this word, quote unquote word, but I think most of you are pretty experienced. You may be able to back into the right answer here. These types of passwords, this is a type of password that is fact or opinion based information used to verify an individual. So I think about, you have a second form of verification for a person, like your mother's maiden name, or maybe the street you grew up on, or your favorite color. It's called a specific type of password. These types of passwords that are fact or opinion based. Yeah, no, I mean, yeah, it's not a hint. No, Pavlov would be proud. Yes, Doug. Did I give it away? Did that give it away? Pavlov reference. Yeah. Yes, Amos, good. That's funny, Doug. Little conditioned response there. Yeah, so cognitive passwords are fact or opinion based. So you probably didn't know that when you filled out your mother's maiden name, or things, maybe where you were born or the street you grew up on, that was actually called a cognitive password. What about this right here? This level. Talked about this yesterday. I even gave a great reference. I thought so. I don't know about the drawing, the drawing of that. Uh, the bird was kind of wonky, but the aviary in that example, and how my mom and dad met from Panama, you know. Jennifer, yes, good. Ryan, good. Alicia, good. Amos, good. Doug, no. Yeah, yeah. So the clipping level triggers the event. Yes, good. Clipping level is what I was looking for there. Good. All right. This will be the last one. Then we'll take a quick break. This is data that is held permanently on a hard drive in the format of a text file or held temporarily in memory. These have been around for a long time. Anyone? Anyone? Yes. Good job, Amos. Ryan, no. I mean, these are for good. They're not. Yes, good. These are for the good of what Facebook says by storing these on your hard drive is they say that it helps with your end user experience. Yes, Doug. Good. These have been around for a really long time. It's a text. It's in a text file, and it may have like the skin that you want the website to look at, like maybe a blue or a red, a theme, maybe some other things that customize the website for you. And you typically have a bunch of these on your website, on your laptop or your cell phone. So cookies are data that are held permanently on a hard drive in the format of a text file or held temporarily in memory. Cookies, right? All right, let's take a quick 8-minute break here. Come on back at 3:20, and we'll keep the dream alive for you.